Something is deeply wrong in the universe. It started with a signal, a strange image captured by the James Webb Space Telescope. At first, it looked like just another galaxy, faint and distant, one of billions. But when scientists looked closer, what they saw shouldn't exist. It was ancient, born when the universe was just a toddler, yet fully formed, structured, massive. A galaxy that had no right to be there. A cosmic monster appearing out of nowhere, as if time itself had been rewritten. And then came the data. Hard numbers that didn't just raise questions. They broke the rules. In the following weeks, more anomalies appeared. Impossible galaxies, accelerating forces. And now, even Einstein's most sacred equation is under threat. Nobel Prize-winning physicists are sounding the alarm. They're saying it openly now. The universe isn't just stranger than we thought. It may be stranger than we can imagine. Astronomers peering through the lens of JWST have detected a monstrous galaxy named J0107A. But this isn't just any galaxy. It existed 11.1 billion years ago, just a few billion years after the Big Bang, and yet it appears fully developed, with a massive bulge, sprawling spiral arms, and a central bar structure eerily similar to that of our own Milky Way. The only problem? That shouldn't be possible. Our current models say galaxies take far longer to evolve into such organized structures. J0107A simply appeared too soon, too massive, and too perfect. According to everything we thought we understood, galaxies in the early universe should have been chaotic, clumpy, and irregular. Forming spiral arms and a central bar, especially one as large and defined as J0107A's, should have taken billions more years. But this galaxy is not only complete, it's enormous, 10 times the mass of the Milky Way. A star-forming powerhouse, generating new suns at a rate 300 times faster than our own galaxy can manage. This isn't just unexpected, it's a direct contradiction to the timeline of cosmic evolution. And then there's the gas. Unlike modern galaxies, which are mostly stars with smaller amounts of interstellar gas, J0107A is composed of 70% gas and only 30% stars. That ratio is baffling in itself, but what's even stranger is what that gas is doing. Observations using both the JWST and the ALMA radio telescope in Chile revealed something startling. Gas is flowing inward through the galaxy's bar at a rate of nearly 600 solar masses per year. That's more than 10 times the flow rate of any known modern barred galaxy. It's as if this early cosmic structure wasn't just mature, it was turbocharged. The existence of such a galaxy in such a young universe is enough to make even the most seasoned astrophysicists stop in their tracks. Xu Huang and his team, who made the discovery, described it as the most massive barred galaxy from that time period, and more massive than almost anything we observe in the present-day universe. But perhaps the most unsettling part is that this isn't an isolated anomaly. A few weeks earlier, scientists mapped another ancient spiral galaxy named Zhulong, dating back to just 1 billion years after the Big Bang. Like J0107A, it too appeared far more evolved than expected. It's as if the universe is littered with secrets we've only just begun to uncover. So what does all this mean? It suggests one chilling possibility. Our models of galaxy formation, the very ones we've relied on for decades, are fundamentally flawed. We've assumed that time, above all else, was the key ingredient for galactic structure. But now, these ancient giants are telling us a different story. One where complexity arrives early and evolution doesn't follow the rules. But the shockwaves don't stop there. At the same time, these impossible galaxies are emerging from the shadows. Another revelation is shaking the very foundations of physics. For over a century, Einstein's theory of general relativity has served as the cornerstone of our understanding of gravity, space, and time. But now, new data suggests that even Einstein may have been wrong, at least in part. At the heart of this challenge lies dark energy, the mysterious force thought to be accelerating the expansion of the universe. According to Einstein's equations and our standard cosmological model, dark energy behaves as a constant. It has no beginning or end. Its density remains the same across space and time, or so we thought. Using the Dark Energy Spectroscopic Instrument, or DCI, in Arizona, researchers have created the most detailed 3D map of the universe ever assembled. By analyzing over 15 million galaxies and quasars, they hope to better understand how the universe has expanded over billions of years. But what they found instead has thrown everything into doubt. Their measurements revealed that the effect of dark energy is not constant at all. The value, known as omega 0, should be 1 if Einstein's theory holds true. But the DSI data came in at 0.838, a significant deviation. And when combined with other large-scale maps, the level of statistical significance continues to grow. In physics, a deviation of 5 sigma is considered a discovery. We're already hovering between 2.4 and 4.2. The signs are mounting. If this holds true, it means that dark energy, far from being an unchanging backdrop to the universe, has evolved over time. Its influence may have once been stronger or weaker and may continue to fluctuate. Some physicists now suspect we're witnessing what's known as phantom crossing, where dark energy oscillates above and below the value predicted by Einstein's equations. It's a cosmic dance we never expected, and one we're only beginning to understand. So what happens if these results are confirmed? It means our current model of the universe, the one built on Einstein's shoulders, will need to be revised, possibly even replaced. It means dark energy, the mysterious force making up 70% of the cosmos, is not what we thought. And it means our universe may be far stranger, more dynamic, and more unstable than anyone imagined. To solve this puzzle, all eyes now turn to the Euclid Space Telescope, recently launched to examine dark matter and dark energy in greater detail than ever before. With every new data set, with every photon of light gathered from the abyss of space, we are getting closer to the truth. But that truth may not be comforting. It may require us to unlearn what we thought we knew and face a universe that no longer plays by our rules. One thing is certain: the age of quiet certainty in cosmology is over. We've opened a door we may never be able to close, and beyond it lies a cosmos that challenges our theories, our limits, and maybe even our place within it.